Now let us study about differential of a product. So let me take this for an example. This is the product of, this f of x is the product of two functions, x and cos of x. One function is x, another function is cos of x. Okay. So how am I going to do it? Or yeah, so let us see. So to understand this, what I would like to do is I would take a rectangle with length cos x and breadth x. Okay, length cos x and breadth x. So the area will be x into cos x, which is what we start with. Now we are going to differentiate this, but this is our original product function. It's a product function. Okay, now what is differentiation? Change in output with respect to change in area. Sorry, change in input. Change in output with respect to the change in input. So let us bring about a little change, a small change in the input. Okay, now what change comes in the output? That is what we need to check. So let us, we have two rectangles here, sorry, we basically have two big rectangles, one like this, one here, and then small rectangle. I know it looks like a square, it does look like a square, but it's actually a rectangle. And you'll come to know that. Okay, let us go for each one. So our length here is cos x. Okay, so this small value here that we added is d cos x. We'll come to that. Look at this. See, our length was cos x, so this small value here is d cos of x. Okay, now, and this whole breadth, was, what was it? It was x. So the length small, it was x value. What the value that we started with. So if I have a doubt, let me keep it. Okay, see, this is the x, so our breadth is already x here, and then this value, small value, is d of cos x. So the area of this small rectangle is this into this, that is x into d cos of x, length into breadth. Okay, now what about the small rectangle down? Not the smallest one, this kind of small rectangle. This value that we added was dx, the small value that we added to x, dx, and this length is cos of x, our original length. So this area of this rectangle is cos x into dx. Okay, now then we have this small rectangle here. I know it looks like a square again, but it is a rectangle. We'll see that because this small horizontal expansion that we had was d of cos x, the same value here and here, d cos x, and this small horizontal expansion that we had was, the vertical expansion was, sorry, not horizontal, this vertical expansion was dx. So what is the area of this thing? D cos x into dx, that is dx d cos of x. Of course you could write it in any order, you could, yeah. So what do we have now? We have this big rectangle, and this tiny rectangle. So that is our change in area, that is a new change in area, right? So let us write that. Change in area is this rectangle, this small rectangle, sorry, this small big rectangle, so that is xt cos x, then this small big rectangle, and that will be cos x dx, and then this tiny rectangle, the yellow one, that will be dx d cos x, cos of x. Now again, dx d cos of x. Dx is a small value, very small value. D of cos of x is also a very small value. A very small value into another very small value will give you a very tiny value. You can check it. Multiply any small value 0.001 into 0.00005. What do you get? You get the you will get that many zeros extra. You can check that. You can check that and see whether I'm telling us what I'm saying is true or not. So therefore this is a very tiny bit of value which does not make much difference. Remember, in all these cases what we are learning, dx is a value which is approaching 0. You should always keep that in mind. Then only this makes sense. So we can neglect it. Let me take that plus also off. Now we have these two things. This is our change in area. Now if you look carefully, you will be able to notice something, and that is, this is our original function, our original product function, x into cos of x. Look at the change in area. So this is the differential, this is the change in output, right? Change in area is change in output, because our function was, we considered the function to be a area function, right? We considered a rectangle and all. So look at the change in output here. This is x, which is our first function. Then this is d of cos x, that is differential of second function. So this is our first function x, second function cos of x. So we started with first function same, we wrote it as it is. This thing we wrote it as differential of second function. Then we had this thing that is same, second function itself. Then differential of first function. So let me just do it again. The first function differential into differential of second function plus second function differential of into differential of first function. So do you get it? Now this is a pattern that is there for all product functions. When you differentiate the product functions, this is a pattern that is always there. And this thing is called, this rule or this equation or this formula is called product rule, because it's applicable for all products when you differentiate. That is, generally writing d by dx of f of x into g of x is equal to f of x into, that is the first function, into differential of second function plus second function into differential of first function. Oh, I forgot the equal sign. Okay, so you get it. So first function into differential of second function plus second function into differential of first function. Now there's another way of learning this, and that is it's not an official way, it's a kind of a rhyming way, a shortcut way. That is, you can remember it like this. If you consider two functions, left function and right function, it will be like left d right plus right d left. D is a short form for differentiation. So I mean, yes, my short form. It's my short form for differentiation, not official one. So left d right plus right d left is the product rule. Don't write anywhere it like this. It is only for you to remember. Okay. Now, by the way, but one thing that I would like you to do is, I don't want you to memorize this like this. I mean, I don't have an issue if you memorize, of course. But I would not like you to. Why? Because now you know why it is coming. You have seen the proof. See, this is not a proof that will be taught to you in the textbook. You can check the textbook, you will never see this proof. The real mathematical proof is solving the f of x plus dx plus f of x, all that thing. It is too long, and might be a little difficult for everyone to understand. So that is why, and also this geometric way, finding the area is a beautiful way of finding it. It's a very simple way also. So since we are done all this, please try to learn it, please try to understand what we really did, and that would be really a good way of thanking me, because as all of you students, a good way of thanking me would be by really trying to learn it by understanding. Now there is one more thing, and that is, and another thing that we need to know is, there is something called as quotient rule, and that is applicable for these type of function division functions, quotient functions. So basically that is why it is called quotient rule. Now there is a proof for this, but the proof is a little complicated. Not that complicated, it's a little complicated, but for that, to prove this proof, you need to learn something that you'll only learn 12th in the next year. So so that is why, since there's already enough for you to learn, and also it's all online classes, and so I don't want to confuse you, so I'm not giving you the proof of this. But believe me that it is a proof does exist. Okay, there is a good proof for this. And if I'm teaching you next year, God willing, if I'm there, just ask me, I'll let you know. Or if anyone really wants to know the proof, give me a message. I'll make a separate video for that person, and I'll send it to that person. And if everyone wants to know, everyone send me a message. I'll make a common video and give it to you all. Okay, now quotient rule is this: d by dx of a quotient function is second function, if this is the first and this is the second function into differential of first function minus first function into differential of second function whole divided by second function whole square. Remember, here there is no differentiation. Okay, this is the formula basically. Second function into differential, okay, let me write it again. Second function into differential of first function minus first function into differential of second function whole divided by second function the square, second function whole square. Or you could use my shortcut method, and that is right d left minus left d right whole divided by right square. Now I know, now there is no left and right here, I know, but if you could imagine, or if you could consider g of x as the right function, this thing would be valid. That is right d left minus left d right by right square. Or you could also learn it as down d up minus up d down by down square. That doesn't sound that good. This would be a little more better. I mean, whichever way you want, you could study in whichever way you want, of course. Just make sure that it's the right way. Now, okay, so that is all. And so basically we have studied all the theory that we need for this chapter. Now in the next video, I'll be giving you a little solving and giving you, for showing you little examples on how to solve these things. Then we'll be closing the chapter. Please, I do urge you to understand what you're really studying. The reason why I given all these proofs is so you can really enjoy and you can really see what you are studying. That the calculus is not a set of formulas and set of rules and all. It's a beautiful way of understanding how things change. Of course, as I said earlier itself, calculus is the max of changing things. So by saying so, that's all, and thank you for listening. Bye bye.